This mini lecture, we're going to look at rational exponents and radicals. So let's look at the first definition that we should be aware of. So a rational exponent will be an exponent such as this 1/2, right? X is the base, the 1/2 is the exponent. It's written as a fraction, so therefore it's known as a rational exponent. The 1/2 is a rational exponent. So anytime something is written as a rational exponent, we can rewrite it as a radical, right? The base becomes the radicand. The denominator of the rational exponent is the index, and the numerator is what you're raising it to. A lot of times in some textbooks, you'll see it as x to the maybe m over n, and then they'll rewrite it as x. The n is the index, and it's raised to the m power, or sometimes in some books they'll say, okay, let's raise the m to x to the m power right there underneath the radical. Myself, I prefer to look at it this way, where first I'm taking care of whatever root we're covering, and then raising it to some power. So this is the definition that you need to understand and be aware of. So let's take a look at some examples. So maybe we'll go with an example such as 25 to the 1/2 power. So again, anytime it has a rational exponent, which it does, the 1/2, I can put the base of 25 as the radicand, the index of 2, and it's raised to the first power. Since it's raised to the first power, I don't really have to write the 1 out there. So now that just means the square root of 25, which is 5. All right, and then I'll do it again. Maybe I'll use, let's see, 81 to the 1/4 power, right? It's not always going to be 1/2 power, to the 1/4 power. Well, it's still a rational exponent. So I rewrite it. The base becomes the radicand. The denominator becomes the index, and it's raised to the first power. So now we're just saying what number times itself 4 times makes 81. I would say that would be the number 3, right? 3 times 3 times 3 times 3 makes 81. Maybe one without a 1 in the numerator. So let's take a look at 8 to the 2/3 power. Well, the exponent is a rational exponent. It's a fraction, so we automatically can rewrite it as a radical. The base of 8 becomes the radicand. The 3, the denominator, always becomes the index. And then the numerator is what you're raising it to. Remember, in the last two examples, the numerator was a 1. So I chose just not to write the 1 because we know that everything is raised to the first power. So here, what we do is take the cube root of 8, saying what number times itself 3 times makes 8. That would be 2, right? 2 times 2 times 2 makes 8. So that's the cube root of 8, 2. But we still have to raise it to the second power according to what we have up here. So 2 to the second power is 4. All right. And then let's go a little bit further and try another one. So this one will be 625 raised to the 3/4 power. 625 raised to the 3/4 power. So what can we do here? We can rewrite it as a radical. 625, the 4 goes in the index, and the 3 is what we're raising it to. The 4 is in the index, and the 3 is what we're raising it to. So now we just have to think to ourselves, okay, what is the 4th root of 625? What is the fourth root of 625? All right, maybe you could think of it, maybe you couldn't. Sometimes you use some scrap paper and then just work through it. But it would be 25. No, I'm sorry, not 25. Let's try that again. That was the square root of 625. The fourth root, let's see. It'll actually be 5, right? 5 times 5 times 5 times 5 gets you 625. So be very careful. Don't make mistakes like I did. Pay close attention to the index. I was thinking about square root when it's actually the fourth root. So the fourth root of 625 is 5. And now we're still raising it to the third power. Well, 5 times 5 is 25 times another 5 is 125. So now let's take this in a different direction. So now we have expressions that are raised to rational exponents. Remember, for all of these rational exponents, we still can apply all of our properties of exponents that we are already familiar with. So when we're raising a power to another power, what do? We multiply the exponents. So we're multiplying w to the negative second. We're multiplying that 2 times 1/4. We're multiplying this 16. What's the exponent of the 16? There's an invisible 1, right? For any whole number, there's an invisible 1 as the exponent. And we're raising that to the fourth, so we're multiplying it by 1/4. And with the v has an exponent of 1/2, but then again, you're raising a power to a power, so you multiply that times 1/4. So basically, I multiplied every exponent in there times 1/4. So let's see what happens. Negative 2 times 1/4 is negative 2/4. 1 times 1/4 is 1/4. 1/2 times 1/4 is 1/8. And then lastly, you always want to simplify all fractions. So we have w to the negative 1/2, right? Because 2/4 reduces to 1/2 over 16 to the 1/4 and v to the 1/8. All right, and then even further, remember in the past we said that we don't want a negative exponent. We don't want that. So how do we get rid of it? By moving its base and the exponent to the denominator. So that will become w to the 1/2 power. And then the v is still there. And you're wondering why I didn't do anything to the 16 to the 1/4. Well, let's apply what we just learned as far as the definition of a rational exponent of a number. So that'll be 16. What kind of root is it? It's the fourth root, remember? And then the fourth root of 16. What number times itself 4 times makes 16? 2. 2 times 2 times 2 times 2. So then that 2 goes down below as well. What goes in the numerator? Well, there was an invisible 1 in front of the w. So that 1 will stay there. The w to the negative 1/2 is the only thing that dropped down because its exponent was negative. So we box that in. So let's take a look at this next problem. We have r to the 1/2 times x to the 3/2 times r to the 3/4 all over x to the negative 1/4 times r to the 1/3. All right, so we just have to remember properties of exponents and what to do. When we have the same base, when we're multiplying, we add, right? And then when we have the same base, when we're dividing, we subtract top exponent minus the bottom exponent. So from what it looks like here, and you can do this in different order, but I'm going to choose to look at the multiplication first, the r to the 1/2 times the r to the 3/4. So r to the 1/2 power times r to the 3/4 power. So you remember the rule, right? For properties of exponents, when you multiply with the same base, you do what? You add the exponents. So here we're adding 1/2 plus 3/4. Well, you just have to use some scrap paper and then add 1/2 and 3/4. Well, they have different denominators, so you're just going to have to find the LCD, which is 4. 2 times 2 makes the 4, so 1 times 2 makes 2. 4 times 1 makes 4, so 3 times 1 will make 3. So that's going to be 5/4. So I'm going to take this step by step. So in multiplying these two here, now we get r to the 5/4 power, right? R to the 5/4 power. And it's still times x to the 3/2 power. So still times x to the 3/2 power. And then that's all over x to the -1/4, r to the 1/3. All right, so now we say to ourselves, I'm seeing the similar base in the numerator and denominator. I see r to the 1/3 and r to the 5/4 power, right? Those have the same basis. So I'm going to subtract those exponents. And also I see x to the 3/2 and x to the -1/4. They have the same base of x. So I'm going to subtract those exponents, the top exponent minus the bottom exponent. So I need to subtract 5/4, right? 5/4 minus the 1/3, minus the 1/3. And I'm also going to have to subtract, what's the other two? 3/2 minus a -1/4. So it's always top minus bottom. So in subtracting top minus bottom, we do 5/4 minus 1/3. We need to find the LCD of 4 and 3, which we know is 12. So 4 times 3 is 12, so we say 5 times 3 is 15. 3 times 4 is 12, so 1 times 4 is 4. 15 minus 4 is 11/12. All right, so when we do that, we're going to get 5/4 minus the 1/3 gives us r to the 11/12 power. All right, now I'm doing the ones I highlighted in yellow, x to the 3/2 over x to the -1/4. You subtract top minus the bottom. Top minus the bottom, which is already a -1/4. So then that's just going to make it a plus, right? Then the LCD of 2 and 4 is 4. So now we just have to say to ourselves, what are the new numerators? What are the new numerators? So the new numerators look to be 2 times 2 makes the 4, so we have to say 3 times 2, which will be 6. 4 times 1 makes 4, so 1 times 1 makes a 1. So we have 6/4 plus 1/4, so that makes 7/4. So that's going to make it x to the 7/4 power. At is something like this. Let's say you have the 1/8 root of k raised to the b power. So I'm just using a as the index and b as the exponent right here. So what you do to take that root, the 1/8 root of k to the b power, you're dividing the index into the exponent. So whatever b divided by a is, that's that root that you've just taken. For instance, let's say we have to take the square root of x to the 6th power. You're just dividing the index into the exponent. 6 divided by 2. which is 3. So the square root of x to the 6th is x to the 3rd. And it makes sense because if you multiply x to the 3rd times x to the 3rd, you add the exponents and you'll get x to the 6th power. So you do this no matter what the index is. If your index is a 3 instead of a 2 or a 4 or a 5, you divide it into that exponent. Now there are times where it won't go evenly into the exponent. For instance, if we have the cube root of x to the 11th power. Well, 3 won't go evenly into 11 like 2 went evenly into 6, right? So when that happens, you drop it down 1. So it becomes x to the 10th. However, 3 doesn't go evenly into the 10 either. So once you drop it down 1 and it still doesn't go, you drop it down 1 more, x to the 9th. Now I know 3 will go evenly into that 9, so that's good. However, we have to multiply times something, and so we're not changing the original problem. So you multiply it times x to the 2nd, right? Because if you multiply these two, 9 plus 2 will get us this 11 back. So you have to multiply it by something that makes it where you're not changing the actual problem. So now what can we do? So let me separate this a little bit. So now what can we do? So we can split it up. We can say the cube root of x to the 9th, and then we say the cube root of x to the 2nd. Well, we said 3 can go evenly into 9. That's what we wanted. So that makes it 9 divided by 3 is 3. So now that comes out of the radical once you do that. However, 3 doesn't go evenly into this other one that we had to multiply it by. So therefore, that stays underneath the radical as it can't be simplified any further. So this is what we're left with. All right. So make sure you just remember those rules for properties of exponents, changing from a rational exponent to a radical, and this one here where we're dividing the index into the exponent.